Hello, my dear friends. So today I'm going to bring to you a very interesting story on heating effect of current, and the story is amp and the heat of the alley. So if you have not subscribed to our channel, I would request you to subscribe it so that you can get interesting stories like this in future also. In the vast buzzing metropolis of Circuit City lived a tiny electron named Amp. Amp's whole life was about moving. He was part of the current crew, and his job was to deliver energy through the wires, which were the city's great copper highways. Most of the time, the journey was smooth, but sometimes the crew had to pass through a tricky, narrow section known as High Resistance District or Ohm's Alley. Ohm's Alley was not built for easy travel. Its walls were crowded with stationary, stubborn atoms, always in the way. More resistance means more effort. Amp muttered, bracing himself. So, as Amp and the rest of the current crew pushed through, they had to constantly collide with those fixed atoms. Bump, scrap. Every collision transferred kinetic energy, making atoms of Ohm's alley vibrate wildly. The more the current crew that rushed in, that's high current I, the more intense the pushing became. It wasn't just a bump, it was a swarm. The heat generated increases with the square of the current because every new electron causes more total collisions. The resistance was another factor. If Ohm's alley was made even tighter, forcing harder collisions, the temperature rose even faster. More R, more fight, more heat. And finally, there was a factor of time. If the current crew kept pushing for longer, the vibrations in Ohm's alley built up and built up, making the whole place warmer and warmer. All the energy from these powerful continuous collisions could not just vanish, it transformed. The kinetic energy of the electrons was converted into thermal energy. This radiant energy, Joule, was the heating effect of electric current. It's what makes a toaster glow, a kettle boil, or a fuse melt when too much current rushes through Ohm's alley. So remember, when the current crew I pushes against resistance R for a certain amount of time T, the resulting heat H is generated. That's the power of the Joule's heating law in action.